Mr. Geisler here, and we're going to take a look at number 11. It says the math club at MIT, which has 12 members, is taking a group photo for the 10th anniversary of the club. They're going to arrange themselves in the shape of a 10 for the picture. The 1 will be a straight line with 4 people. The 0 will be a circle with 8 people. How many different arrangements are possible if there are no restrictions on where anyone stands? So let's set this up before we get the answer. The first thing is that we have 4 people that are going to make a line. Since there's 12 members, there's 12 times 11 times 10 times 9 different possibilities for the 4 people that will stand in the line. So these are the people that will make up the 1. Now, the people that make up the 0, there's going to be 8 of them. So I'm just going to go ahead and do 1, 2, 3, 4, 5, 6, 7, 8. So you could do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's going to be one arrangement. Now, they're in a line there, but if you can just imagine these people that this person will walk around here and they'll just form a circle, that's going to be the order that they're going to be in. However, because it's a circle, the arrangement that matters is just who are you standing next to. So in this case, 1 and 8 are standing next to each other. Now, if we think about this, not really in terms of the number of people, but just this is person number 1, person number 2, person number 3, person number 4, person number 5, person number 6, person number 7, and person number 8, I can rearrange them simply by moving the 8 over to the 1. So for 7, 6, 5, 4, 3, 2, 1, 8. Now, this is actually the exact same arrangement when I go into a circle because 8 and 1 are still next to each other right here. And I could do that again by sliding them over. And 6, 5, 4, 3, 2, 1, 8, 7. So again, if they make a circle, they'll still be in the same arrangement. Well, you can do this a total of 8 times. So in the first one, to figure out how many people there are, I could just do this by doing 12 P4 because the order matters. So I'm going to take of the 12 people, I'm going to choose 4 of them. In the second one, since I'm using all of them, it's just going to be 8 factorial. But because there's 8 different arrangements that mean the same thing, I have to divide that by 8. So then we want to multiply those two together and see what we get. And we get a total of 59,875,200. So 59,875,200. Now the second says, how many arrangements are possible if the 4 club officers must be forming the 1? Well, if we do that, then there's only going to be 4, 3, 2, 1 to choose from here. So that would be 4P4, and then we're still going to multiply by 8 factorial over 8 because that part hasn't changed, which will equal 120960.